In this lesson, I want to discuss a study illusion that fast, easy retrieval does not necessarily indicate strong cortical memory traces. And we'll have to assume here that you've already watched the previous lessons in this series on how brains are making memory traces and the importance of the communication between the hippocampus and the cortex in consolidating memories in our long-term system. So here we have a brain after we study one time. We've got our cerebral cortex, and these little icons here will be memory traces that have formed as a result of the learning episode. After one study session, we're left with relatively weak cortical memory traces indicated by the small terminals here. What we want are strong cortical memory traces indicated by the larger axon terminals there. So of course, to go from this to this, we might need to study repeatedly with sleep in between so that our hippocampus can fire up the recently learned memory traces and strengthen those cortical memory traces. So it takes work to go from weak cortical memory traces to strong cortical memory traces. But this is the brain that knows something. We're going to have a far easier time accessing our stored information if it's stored with strong cortical memory traces. Now here we're going to introduce some new terminology. When we have a memory trace in our cortex, but we're not currently activating it, and it hasn't recently been activated, we're going to call it a dormant memory trace. So what is a memory in the brain? It's a pattern of strengthened synapses among some of the neurons involved in the learning event. You'll recall when we were seeing something or hearing something, some population of neurons gets activated, and a subset of those neurons will grow stronger connections with each other, forming a network that represents what we saw and what we heard. So a memory trace then, when we're not using that information, it just exists as a set of strengthened synapses among some neurons that were activated during the learning event. So that would be a dormant memory trace. So you have all kinds of dormant memory traces right now. They're in your brain. It's when we reactivate those memory traces that we retrieve the information. But the memory traces were there as a pattern of strengthened synapses. Now we're going to introduce some more terminology here. So a memory trace can be in 3 different states, and we've just seen what we mean by a dormant memory trace. In fact, most of the information stored in our brain at any given time exists as dormant memory traces. But there are 2 other states as well, an activated memory trace and a recently activated memory trace. And we'll see the distinctions between all 3 as we continue with the lesson. So let's take a look at these 3 activated memory traces. Of course, this is happening when we're in the learning process itself. So again, when we see stuff and hear stuff, some set of neurons gets activated, and then a subset of those neurons are going to grow stronger connections with each other, forming a memory trace for the learning event. Of course, it's also true that when we retrieve a memory, those memory traces will be activated as well. Now let's consider the third kind of memory trace, a recently activated memory trace. Let's start with the brain up here. We have weak cortical memory traces for some information we're studying, perhaps because it's our first study session. But you may have experienced this, that when you're learning new information, say you were reading a passage in a book or something, or watching a video lesson, for a short time afterwards, you have fast, easy access for the information you were just previously processing. So even though we might have weak cortical memory traces, there seems to be something going on that is giving us access to that information for some short time after we just studied the material. So what could be going on? Apparently, the activation of memory traces makes them easier to reactivate for a short time afterwards. And why would that be? Here's the idea. There is a temporary increase in synapse strength. So take a look here. Notice the weak synapses are now a little larger. Here you can see the red tips on the axon terminals, and that is intended to represent that because these memory traces were recently activated a moment ago, they enjoy a temporary increase in strength of these synapses, making the memory traces easier to reactivate in the immediate future. So Because the memory trace was recently activated, the synapses are temporarily stronger, and in a previous lesson I identified that as sort of the working memory boost. We had just been either learning this information or retrieving this information, and we had a conscious experience of the information in our working memory. And so for a short time after that, that information is more easily accessible. We called that the working memory boost. And what scientists think is going on is there's a temporary increase in the strength of the synapses amongst those neurons involved in the memory trace. Now, this is temporary. We're using that word temporary, so it's not yet a long-lasting increase, and that requires biological growth. But the memory traces are easier to reactivate for a short time. So successful retrieving during study sessions makes memory traces appear stronger than they might really be. So over here on the left, we are studying, and as a result of that studying, we have memory traces that have a temporary increase in the synapse strength there. So those memory traces are going to be easier to reactivate in the immediate future. And to us, when we're studying, we might think that, we know the information. I was just reading the information. I put the book down for a moment. I can retrieve that information easily. Well, that easy retrieval may be due to this temporary strengthening of the synapses amongst the neurons in the memory traces. So we need to be careful here. A weak memory trace could appear to be strong because of this temporary increase in synapse strength. Now, it takes time for the biological growth to go from weak synapses to strong synapses. That takes time, more time than the length of our study session. You'll recall we need to go to sleep and do consolidation during sleep, and we might have to study repeatedly. So to get these strong cortical synapses, that's going to take some time, much longer than a single study session. But the issue is, during a study session, the temporary increase in these synapses can make it seem as if we have strong cortical memory traces. So the key metric for judging our long-term memory is the strength of the dormant memory traces. So if we want to know whether we have something well stored in our long-term memory, we have to test the strength of the dormant memory traces. So we want to see how strong those synapses really are in the dormant state. Do we have weak memory traces, or do we have strong memory traces? So the success or failure of retrieving dormant memory traces will give us a better indication of the strength of the long-term memory. So again, the concern here is that we can't make a judgment about our long-term memory when the memory traces have recently been activated. So if we're in a study session and we're processing some information, because of the temporary increase in these synapses here, I'm going to feel like I have easy access to that information, and I might mistakenly conclude that that easy access means that I have really strong memory traces in my cortex. But I'd be wrong. It's really just this temporary increase in the strength of these memory traces. So what do we do then? How are we supposed to test the strength of our memory traces in a dormant state? Well, we have to study after a delay. We've got to let the temporary increase go away. Ideally, the delay should include sleep. See, so when we study each day, we are creating long delays, and that guarantees that when we study the next time and try to retrieve information, we're working with dormant cortical memory traces. So here we have the study illusion. Over here on the left, here we are studying, and we're processing information, and we're forming cortical memory traces here. But then we put the book down, or a moment later we try to retrieve information, and we find we're really successful. So we might think we have strong long-term memory traces because of that easy retrieval. See, we think our brain is like this up here just because we had easy access to the information a moment after studying it. But what might really be going on is that we still have weak cortical memory traces that are just temporarily strengthened due to the recent study session. So the study illusion then would be we interpret fast, easy retrieval during a study session to mean that we have strong memory traces in the cortex. That might be false. So let's revisit then the three different states that a memory trace can exist in, and then we'll use these terms to restate the study illusion. Dormant memory traces, they have not been recently activated. An activated memory trace is when we are sort of attempting to retrieve that information. So we're loading up into working memory. And by the way, we can think of working memory really as just activated long-term memory traces. And then recently activated memory traces, these are ones that enjoy a temporary increase in the ease and speed of activation in the immediate future due to the temporary increase in synapse strength among the neurons in the memory trace. The study illusion and how to avoid it. Most of the information stored in the cortex at any given time exists as dormant memory traces. As we said before, a memory is a pattern of strengthened synapses as a result of a learning episode. When we retrieve a memory, activated memory traces remain at an elevated level of accessibility because synapses are temporarily stronger, making the memory trace more easily reactivated. Recently activated memory traces will appear easy to access, which can fool us into thinking that we have strong cortical memory traces for this information. We must test the strength of long-term memory traces when they are in the dormant state, not after recent activation. How do we do that? We do our memory test after a delay, preferably with sleep in between.